Hello. Okay. Actually, put this guy over here. Okay. This won't be crazy long, hopefully. I want to go read with my girlfriend. So I've got musical loud, no? Whatever. So I've actually written the server already, but I'm working on the extension exercises. Just trying to remember. It's been like 10 days since I've worked on this. So if I run the server, the expected behavior. Oh no, I won't be able to hit it off. So that if I look on port local, if I look on localhost at the port, and I ask it for a file, it gives it to me. Okay, so that's where I was at. So if I'm just going over how this works. So we're using the Python socket API. And what the server is doing, you spin up a socket, you set the port and stuff, and we're checking if the user passes an argument when they call, like when they spin up the server. We're parsing what they pass in as the port. So it's a server that by default runs with some explicit port, but can take one from the user. Interesting. Too many values to unpack. Oh, the server just crashed. There's some shit needs to work on. Next, we bind. We call sucked up. We call the .bind method, which takes a tuple as an argument that is an address and a port. But if you don't give it an address, I think it just looks for any locally running addresses. And then you run the listen method of the socket. And while true, so this is just the infinite loop. So when the server receives something from a client here, it spins up this new connection so that you can keep one socket open listening for incoming clients, and then you use a different socket to handle the request from the client. And with the socket package here with Python, we can directly take out this, or just like grab the objects for this new socket and the client's address, like IP address, using the accept method. So we're permanently looping, listening for requests from a client. And when you find one, you start another loop, and you take in the data using the inside its own loop. You're receiving a certain amount of bytes at a time from the client using the receive method, and if if you're not receiving anything, you break out of this inner loop because you've received everything from the client. But if not, you're keeping track of everything you're receiving cumulatively from the client. And if you come across the \r \n, which is how, I guess, like that is the line between the HTTP header and the body, I think. Because the headers look like the client's going to send a request to a server that looks like this. So at the end of this line here is a \r \n, and then you get the host, localhost, connection close, and then \r \n. But it's when you get two of them, it's like a line here, and because I guess I'm just parsing out. Because in this particular server is just needs the request line basically to do the stuff it's doing. Like this is sort of just trying to deliver a file that the client asks for. So yeah, the client sends this line here, And that's all we need to do our stuff here on the for this exercise as part of his book. So we've got this cumulative collection of the bytes we've received from the client. Then we decode it according to whatever standard we're using, ISO 8859-1. And then yeah, I'm extracting the headers part. Whatever else. What's that called in Python? Like a temporary or throwaway variable. I thought there was a special word for that in JavaScript. But yeah, we're getting a headers part, whatever else, and then the body from this newly decoded chunk of data we've received from the client. Sorry, I love some wings. What, pizza? My gosh. All right. I guess I've sent the text. So yeah, we've got this decoded chunk of data we've received from the client. We've taken the headers and the body from it. Well, in particular, from this headers part, which is these lines here, we take out. I'm getting the request line, which is this first line here, and from that I'm getting the request method, the path, and the protocol. So yeah, in the example here, if in localhost here on the client, if I ask for localhost / at the port number / file1.txt, in the directory my server is running, I've got such a file. I have an actual text file here, and that's so that path to that file is what this path variable will be now used to find. So yeah, request method, path, protocol we get from this top line here. And I'm getting yeah, to get the file, I split that string on the /, and I take the second to last thing that's there, which in this case, yeah, I could have taken the first index, which would be the second thing. Have request line, request method, path, protocol. And then I parse out the type of the file type by splitting on the period character and taking whatever's last in that collection of strings, which will of course be .html or txt or JPEG. Yeah, so and then using according to that file type, there's a term for it, MIME, and getting an HTTP. The payload can be anything that any collection of bytes. How does the web browser know how to display it? The answer is the content type header, which gives the MIME type of the data. This is enough for the client to know how to display it. Some example MIME types. Oh yeah, so the client asks for this file. It asks, hey, do you have text file1.txt? The server has to return whatever it's going to return, but it needs, in its header, the reply from the server needs the content type line, and there's specifically allowed things you can put there. So if it's HTML, oh, I guess it's right here, But yeah, what my program's doing, if that text, if the file type is HTML, the content type when we return it from the server, it needs to be text/HTML. Similarly, if the client asks for a text file and we're returning it with the server needs a content type in its header. That's text/plain. So that's it if it's .txt. If the client wants .txt, if the client wants .jpeg, the server needs to return again the content type header image/JPEG, PDF, application/PDF. I'm guessing there's more. I've just done these ones because stuff, yeah. Because then you, yeah. So you've got this file type you've parsed out of the request from the client. So we're gonna try and open such a file. Yeah, we're gonna read the file. If we were able to find that file, if successfully finding the file the client's asking for succeeds, we're spinning up this little what's it called in Python? A tuple? Or I guess just this is like a list of strings. Sadie's good. Yeah, so we're bringing up a list of strings here, and these reflect what the header would be in the response from the server in this instance, which is that we've found this file the client's asking for. So in that case, in the response, a response from the server is going to look something like this. So we're returning this line, the protocol, and then the status code. 200 OK. I mean, yeah, we found your file. Here it is. And then those content types we were just talking about. The content length. This is the length of in bytes. The length of data. This is the length of the file. So the client's asked for a file, the server is returning this file, the contents of it, but in order to do so, the HTTP header needs to know how big the file is. So that's just the size of the file there, or the length of it in characters. And then this, I don't know what these lines are called, but the header will say something like connection closed. So this would be I guess this is your behavior for repeat requests, I think. So I actually kind of need to look into that more. If it's connection close, when the client gets what it's asking for, the server sends it back, has a header connection close. The socket the server spun up when it received that first request from the client will be closed. I think that's how that works, because I think that's how that works. There's also connection : keep alive, which I think keeps the socket open. So I guess you don't have to like handshake when you're sending stuff back and forth. Maybe, I don't know. And then, so then we encode that data according to the same standard we unpacked it when we received it from the client. And yeah, so data. And this variable data, this is the contents of the file that the client asked for and that the server has succeeded in finding. Headers is this list of strings we've just spun up. And so the response the server is going to send is just header plus data. And be sure to put \r, \n, \r, \n between them. And then if we're not able to find the file the client's asking for, the server just returns a similar object. So the response that the server returns is the same line here, except it's going to be 404 not found. The content type is going to be text plain, because all we're going to be returning is like a little message that's like we weren't able to find what you sent. So we're going to send 404 not found as the actual content. And the length of that in bytes is 13. There are 13 characters there in that string 404 not found. Then content length, so content length is the length of that. Content type is text plain because we're just returning 404 not found, like as a string. Connection I have is keep alive again. I don't know, I'm not sure if that's great. You should probably close it if you're not able to find a file. Oh, but we want to keep these connections alive just because regardless of whatever string or a file I'm asking for in my client here as the browser, I guess, whether or not that file actually exists, I don't want to close the socket, but I guess that's not where we want to do that. I should probably be checking for that. Unicode. I'll come back to that. The next couple little things I need to figure out relate to how we actually service the files. I'll worry about the delegation of side sockets and keeping those open or not right after. Yeah, so whether or not we found the file, we've addressed what the response is from the server, whether the file exists or not. And now, when that new socket you spin up, when the client sends something, asks for something, it's time to send it back. It's time to use send all. You just give it the response that we just spun up, and then you close that socket after it was sent stuff. Okay, so the extension stuff at the end of this chapter. So add MIME support for other types so you can serve JPEGs and other files. So I already did this. Add support for showing a directory listing. If the user doesn't specify a file in the URL, show a directory listing where each file name is a link to that file. File is path.split at minus.
Hey Pro Painters. With Behr, you're getting paints, stains, and primers at everyday low prices. Plus, same day.
Add support for showing a directory listing. If the user doesn't specify a file in the URL, show a directory listing where each file name is a link to that file. os.listdir. Return a list containing the names of the entries in the directory given by path. Add support for showing a directory. So right now we get it by splitting on slash. If I print the file, file1.text, but if path.split, request method path and protocol, request line.split. Get file. But if I don't ask for a file, get slash and HTTP. Okay, so we just need to be a little more robust about how we ask for the files then. So if path is just a print nice. Need path, need directory here. So if path, then you show else, and that's just the entire rest of my program. You tab in. Pressing V, select lines 1 and down, and press V. Doesn't work. Right, alright. So now files is os.path.lister. os.list dir. Used to list all files and directories in a specified directory. If no directory is provided, it returns the contents of the current working directory. os.list dir. Files equals os.list dir. Print. cat.jpg file.txt. That's all the files. So I'm supposed to add support for showing if the user doesn't specify a file in the URL, show a directory listing where each file name is a link to that file. Okay. I'll be right back. I have to go to the bathroom. It's so bad. Burb. Fucking dumbass. Oh my god. This takes me so long. I think that's it, folks. eat some dinner.